Ferris wheel to fairground rotates in a vertical plane. So that all that means is that we could kind of slice it through like a piece of paper, and it's not sort of wobbling left and right. It's just basically going around in 2 dimensions. So let's say it's going around like this. Then the height above the ground of a seat on the wheel is h meters at time t, after the seat is at its lowest point. The height is given by this equation, where k is a positive constant. Write down the greatest height of a seat above the ground. So for this, you need to remember that cos actually varies between 1 and -1. So the greatest height is going to be actually when cos is -1. Cos of kt is -1, but I don't need to worry about that. Just cos the function is -1. So then I'm going to get 15 plus 14 is going to be 29. 29 meters. And then the least height is going to be when I'm minusing the maximum of cos. So this time 1. Therefore 15 minus 14, it's going to be 1 meter. Nice. Given that a seat first returns to its lowest point after 150 seconds, calculate the value of k. So when t is equal to 0, we're going to have h is this 15 minus 14 times cos 0, so 1. So it's at the lowest point then. And then let's take a look at 150 seconds. Then it must be that, because we're told again it reaches its lowest point, it must be that 15 minus 140 cos 150k is again equal to 1. And we've got a trig equation to solve. So I can rearrange this. It must be that, okay, I kind of maybe have made this unnecessary, but I'm rearranging it, and I'm going to again get cos 150k is equal to 1. So that means 150k. We know it's not going to equal 0. It's going to be when cos next hits a maximum, and that's going to be 360. So k is going to be 360 over 150, 36 over 15. Actually, that is 12 over 5. Of course, you can put that in your calculator if you prefer. So I just want to say again, it was a bit unnecessary to like set up an equation and solve it. I could have just realized that cos had to be 1 again, but I played it safe and it worked out, so it's not a big deal. Okay, then determine for how long a seat is 20 meters or more above the ground during one complete revolution. So let's say here is 20 meters. How long? So what we can do is find the times when the seat is 20 meters above the ground, and we can subtract them. That will tell us the duration that it is then above 20 meters. Okay, so this time, definitely going to need to set this up as an equation. So 15 minus 14 cos, we know it's 12 over 5, t is equal to 20. I can rearrange this. So 14 cos 12 over 5t is going to equal minus 5, because I've added the cos on and then minus the 20. Okay, and I've got this to solve. So I just need to do inverse cos of minus 5 over 14. Which gives me 110.924. There's going to be a second solution though, because I've got this one here. That's my first solution that my calculator's found, but there's another one here. and there's a line of symmetry going down, we do 360 minus that. I always use the graphs. You can use cast diagrams if you prefer. Okay, and then to get my time, I got to times by 5 and divide by 12. Which gives me 46.218. And then my other one, okay, so I'm just getting back to that 110. Right, now I'm going to do 3. I'm going to try and use my exact answer. I could have stored it in my memory, to be fair. But anyway, right, that is my second solution. Now I'm going to times that by 5 and divide by 12 to give 103.781. So just to reiterate, times when seat is at 20 meters. So the duration above 20 meters is going to be the difference. $57.563. I think it said to the nearest tenth of a second, so at this point I'll round it, but not before 57.6 seconds. Okay, nice trick question there. Well done.